Hi, I'm Max from Laguna Tools, and today I'm going to show you how to create landscapes kind of like these using freely available data online. I'm going to break this project down into 3 parts. The first part is to go online and find what's called a digital elevation map. We'll download that, and then in part 2, we'll process it until it becomes a 3D model. In part 3, we'll bring that 3D model into Aspire and toolpath it to prepare it for milling. Other than Aspire, you're going to need 3 programs in order to do this project, and you can find the links to download those in the description box for this video. So as I said, the first step of this tutorial is to find a digital elevation map, and to do that we're going to use nationalmap.gov's download browser. If you click the link, it'll take you to where I am right now. And basically what you're going to see is a map. Up above that map you get a search box, and then over to the left those are your data sets. Now there's a lot of information, a lot of really interesting information about the United States in these data sets. The one that we're interested in for this project is elevation products. And that's going to give us our digital elevation map. You're going to get some subcategories, and those are resolutions. The one that you want is 1/3 arcsecond, and the reason why is because the entire United States has already been mapped in that resolution. It's the highest resolution available for the United States. Although you can see that some areas have actually been mapped in 1/9 resolution or even 5-meter resolution, but 1/3 is completely sufficient for this project, so just choose that, and then the next step is to find a location. So in the search menu, you can pick any location, you can pick where you're at right now, but just bear in mind that flat areas won't look like much because we are just looking purely at the elevation. So I'm going to pick Mount Hood just because it happens to be a mountain and there's a good difference of elevation there. Go ahead and pick your location, type it in, and when you're happy with that, click the button that says Find Products. That's going to give you a map. And if you click the button underneath that says Show Footprint, you should see a border around your area. It may be a lot larger than what you actually need, but you're going to download that entire map, and then the next step we'll just select the area that we want from it. So keep in mind where within that footprint, the location that you actually are interested in, where that is. And once you're happy with that, click Download. And that's the end of this step. You're going to get a zip file, so go ahead and unzip it, and then we're going to switch over into our programs. You're going to need to download 3 programs for this tutorial. The first is QGIS, the second is 3DEM, and the third is Accutrans 3D. All of those are available to download, and the links are also in the description box below, so you can go ahead and download those. The first 2 are free. The third one costs $20, but it has a 30-day free trial, so you have that long to decide whether or not you want to continue doing this a lot. If you do, it's only 20 bucks. So go ahead and download those and join me in part 2, where we'll take this and turn it into a fully 3D model. So in part 2, we're going to start with this unzipped folder. And if you're new to this kind of stuff, you're probably seeing a lot of files that don't really make any sense. What I'm going to do is just tell you where the file is that you're going to start with. If you open up that folder, you'll see 2 other folders. One says Info, and the other one has kind of a coordinate on it. That's the one that you're interested in. It won't be the same name as mine unless you also chose Mount Hood. But go ahead and click on that folder. And then within there, you're going to see a bunch of files. One of them will be a lot larger than the other one, and it should be named the same thing as the one that I have. So that's the file that you're interested in. That's what we're going to start with. And the program that we're going to start with is QGIS. So while QGIS opens, just a brief introduction. This is a massive open source project that does a lot of different tasks for cartography. We're barely going to scratch the surface of what it can do in this project, and basically we're going to use this to crop out our image, convert it into an unusual file. It's an image that's attached to an XML file. It's called a geotiff. Alright, we're up and running, and I know this interface looks really scary, but what we're going to do inside this program is very simple. Just head on over and click that square button. This says Add Roster Layer. Go and find that file in the folder that we looked at earlier. Open up that, and you're going to get a map. If you look at the toolbar at the top, there's an option called raster, and if you scroll down you'll see extraction. Choose the clipper tool, and this is going to allow you to crop out that section of this map that you were originally interested in. And I advise actually choosing a very small section of the map, because even mountains are relatively flat if you crop out a huge area. Just click and drag over whatever area you want to continue with, and then choose the output location for your geotiff. Go ahead and open up 3DEM, and it's going to give you a menu. It's going to ask what kind of file you have, and you just exported a geotiff, so if you guessed geotiff, then you're right. Open it up, and you should get a map. You're almost done. All you have to do is click File, Save as usgs.dem, save that out, and we are done with this program, and most of the way towards getting a fully 3D model. So the last program that we're going to use for part 2 is called Accutrans 3D, and this is going to convert that file that we just created into a 3D model that you could take into Aspire or really any 3D modeling or CAM software that you choose. I'm not going to lie, it's a nightmare of buttons and menus. So just follow along. I'm going to show you the features that will be helpful for bringing this file into Aspire later on. So to get started, we need to open up that .dem file. If you look up at the top, there's a button that says Open. Click that, find the file and open it. And you should get a very strange visualization. If you look over to the left, there's a button that says 3D, and it has a little mountain over it. That's going to convert it into a 3D model. But before you get to the 3D model, you'll get a menu screen. On this menu screen, you can choose to lower the vertex interval. If you want a more accurate model, you can lower that number to 4. I don't recommend going lower than that. These are huge models. So click OK, and your model is going to replace that original visualization. And you can left click and drag the mouse around to rotate this and get a better sense of what it looks like. To prepare this for Aspire, there's a few things that we can change. The first is we really don't need the texture that's being applied to this model. So under Tools 2 up at the top, there's a button that says Erase Texture on All Layers. Click that and you should get a white 3D terrain. Just below Tools 2, there's a button that says Adjust Object. If you click that, it'll give you a menu on the right hand side, and you'll see X, Y, Z inputs about halfway down. If you change the Z value to 1.5 or 2 times and you click Scale, it'll scale the model only in the Z direction. After you're happy with the overall appearance of your model, you want to click the button that says Center X, Y, and Z 0. That's going to put it in more or less the location that you want when you're bringing it into Aspire. Then click OK at the bottom to confirm your changes. Now all that we need to do is save this file out. So up at the top you're going to see a bunch of choices for how to save this. You want to choose the one that says Option underneath it. Click that button and you're going to see, well, probably way too many options. But the button that we're interested in here is called Use Units. Click that and you're going to get a menu screen that shows you the actual size of this model in real world space. It's huge, that's meters. And the scaled size, which is the size that you're going to output this file at. So you can leave input as meters, change the output to inches, and then lower scale factor 2 until your scaled size is slightly larger than the actual area that you want to cut. When you change the scale factor to, you're going to click Update SF to confirm that change. It will show you an updated scaled size. And when the measurements are about right for you, click OK. Then click Save and close out. Alright, so you made it to part 3, which is Aspire. And I'm going to walk you through the basic setup and 3D toolpath for the terrain. First, you need to open up a new document, and you're going to get a menu screen on the left-hand side. The important thing here is that you make the boundary a bit larger than the object that you intend to mill. So in my case, I'm going for a 6" by 6" block. I'll make the boundary 8 inches by 8 inches. I'll set the max Z to the stock thickness that I have. I just happen to know that mine is 3 inches. Whatever stock you have available, that's what your Z should be. And finally, make sure that you choose high resolution. When all that's done, click OK. Next, let's create a rectangle. This is going to be a boundary for the 3D toolpath. So even though our overall boundary is 8 inches by 8 inches, it won't cut the 3D element outside of the 6" by 6" boundary that I'm about to set up with this rectangle. Click the rectangle, place it in the center of your file, and make the boundaries whatever is appropriate for your project. Mine is going to be 6 inches by 6 inches. Great. Next, we're going to add the model to our document. What you want to do is go File, Import, Component or 3D Model, and choose the STL file that you just created in AccuTrans 3D. Once it's loaded, you'll get a menu screen asking you to orient it. We've already done a lot of the orientation in AccuTrans 3D, so all you need to do is select Back at the very top, scroll down and click OK. You might notice that the model is at the bottom of your stock, which is somewhat wasteful. To fix that, double-click the file in the component tree. From here you can increase the base height so the top of the model matches the top of your stock. And now we're finally ready to toolpath this. On the right hand side, you'll see the toolpath menu. Open that up and pin it. I'm not going to specify which tool you should be using. It's a 3D object, so you should be using a ball mill, and if you're doing something about the same size as me, I recommend an 1/8 inch or even a 1/16 inch. Beyond that, it's really up to you. Now, under Machine Limit Boundary, choose Selected Vectors. Leave Area Machine Strategy on Roster, but change the angle to 45 degrees. And the reason why is because with this angle, it's going to plunge into the corner and begin slowly eating away at the model. So you can actually skip the roughing pass in relatively soft materials like MDF, wood, or foam. And select both the model and the vector. That's it. Click Calculate. With the toolpath selected in the toolpath list, you can click Preview Selected Toolpath to see a preview of your outcome. Assuming that that's good, close out and click the Save Toolpath icon. This is where you need to choose the post processor that is appropriate for your CNC. If you're using a Laguna SmartShop 2, you'd be using the same one that I am, the Laguna SmartShop BR-ATC. It's a .prg file. You'll need to select your toolpath again in the toolpath list and then click Save Toolpath and put it somewhere where you can find it later. That's it. Now you can go mill it. I hope that you enjoyed this tutorial, and I look forward to creating other videos covering skills within the range of 3D modeling in CAM.